The problem of non-stationarity is quite a serious issue that we need to know how to deal with, because if we don't correct for non-stationarity, we might get spurious results. And spurious regression, this is a type of regression that provides misleading statistical evidence of a linear relationship between independent non-stationary variables. So in very simple words, if you run a spurious regression, you will receive statistically significant results, even though in reality the variables have no causal effect on each other. So you will actually get fake results. You will say that there is a statistically significant relationship between two of your variables, but in reality, there will be no statistical relationship. Therefore, please be careful and use one of these tests to check your time series for non-stationarity. There are a lot of unit root tests, first generation, second generation unit root tests. Those are the simple ones. They're called first generation unit root tests. The most famous one is Dickey-Fuller test, which has been later augmented by Dickey-Fuller and now has the name of the augmented Dickey-Fuller test. And there is also another type of test, the Phillips-Perron unit root test. Let's have a look at the Dickey-Fuller test. And before we have a look at it, let's rewrite the first equation where yt was just a function of yt minus 1 plus the error term. So now let's add the rho coefficient. And if rho is equal to 1, we will say that there is a unit root problem or that y is a non-stationary process. We already know this is a random walk without drift. However, if rho is lower than 1, then we say that there is no unit root, or in other words, y is a stationary process. As you can see, such terms as non-stationarity, random walk, unit root, and stochastic trend can be used very much synonymously. Unfortunately, we cannot estimate this equation directly and test the hypothesis that this rho coefficient is equal to 1 by the usuality test, because the test is very, very biased in the presence of a unit root. But what we can do is we can take y from the previous period and subtract it from both sides. So when we do this, we get the following expression. So on the left side, we have yt minus 1. And on the right side, we have rho yt minus 1 minus yt minus 1 and plus the error term. We can factor out yt minus 1, and we get rho minus 1 is multiplied by yt minus 1 plus the error term. We already know that the difference between the variable in the current period and its value from the previous period is just the first difference. Therefore, this expression can be alternatively rewritten as delta yt is equal to delta yt minus 1 plus the error term, where the small delta is just this brackets rho minus 1. Therefore, testing whether rho is equal to 1 or different from 1 is the same as testing if delta is equal to 0 or not equal to 0. So if delta is equal to 0, then we say that y is a non-stationary process, that there is a unit root. However, if delta is found to be different from 0, then there is no unit root, and we say that y is a stationary process. And now let's see how the model from the previous slide is utilized by various unit root tests to check for the presence of a unit root. And on this slide, we have three formats of the Dickey-Fuller test. As you can see, there are three types of model: random walk with drift, and random walk with drift around a deterministic trend. So a random walk, this is just the model from the previous slide, where delta yt is equal to delta yt minus 1. A random walk with drift, so the first model is just amended with an intercept, and the third model, random walk with drift around a deterministic trend, this is the second model amended by the trend. And the null hypothesis of all the tests is that delta is equal to 0, so that there is a unit root, or the time series is non-stationary, or it has a stochastic trend. And the alternative hypothesis is that delta is lower than 0, which means that there is no unit root and the time series is stationary, possibly around a deterministic trend. And another type of test, Dickey-Fuller test, but this time augmented, And it is considered to be superior to the simple Dickey-Fuller test because it allows for serially correlated error terms. So if autocorrelation is present in your dataset, unfortunately Dickey-Fuller test cannot be trusted. However, instead you can use augmented Dickey-Fuller test. And from this expression you can get that it is very much similar to the previous models, with the exception of the presence of this sum term, where the model is amended by adding the lagged values of the dependent variable. And the null hypothesis is the same as in the Dickey-Fuller test, so delta equal to 0, which means that there is a unit root, and the alternative hypothesis is that delta is lower than 0, which means that there is no unit root.